another term to be introduced. It is called as initial phase or EPOCH. It is called as epoch. Okay. The technical name for initial phase is epoch. EPOCH, which is represented by the symbol phi and a circle at the bottom. You read it as phi naught. Okay. Or some books represent it as theta naught. Generally, that naught means initial. So, what I'm going to say here is observe. Okay. Do you guys remember how we derived y is equal to a sin omega t? From where did we get that expression? How did we know that this is how the expression for a particle in SHM should be?
From y equal to a sin theta.
From where did we get? How did we know that y is equal to a sin omega t? Who told us actually? We took the reference of which motion and tried to convert it to SHM.
Simple harmonic, sir.
No. We try to take the help of uniform circular motion and try to project it as SHM, right? See, let me ask you one question. If there is a particle which is oscillating, is it moving in a linear path or a curved path?
Curved, sir.
No, when a particle is oscillating, okay. Let's say there is a particle like this, it is going to the right extreme, again coming back to this, going to the left extreme, again coming back to the mean position. Is it moving in a straight line path or a curved path? You look at this, no, I've drawn the diagram.
Straight
What did I
line,
do?
sir.
It's a straight line, right? For a straight line, where does this omega come from? For a straight line, how are we able to define angular frequency? Angle means something has to rotate, no? So we are able to write the expression for simple harmonic motion in terms of omega because we are taking a relation between a uniform circular motion and SHM. So if someone asks you, where did you get that expression from? You actually got it from where? From the similarity of uniform circular motion. Okay. And if you recollect it again, the particle started from this point and it was here at some point P dash. Okay, this side took it as t is equal to 0. This side took it as t is equal to some random time t. I don't know what it is. At some time t. Am I right? Now tell me, t is equal to 0 if it is considered as initial point, and I call this OP as a position vector or radial vector of radius a. What is the initial angle made by the radius vector with respect to x-axis? What is the angle made by the initial radial vector with respect to x-axis? Initial radial vector means OP vector. How much is the angle made by OP vector with respect to x-axis?
Theta.
With respect to x-axis, OP with respect to x-axis, it is 0. It is 0, right? Because OP is coinciding with x-axis. So, what I'm trying to say here is, the particle started with an initial angle of 0 degrees. Are you guys able to understand? So, y is equal to a sine omega t, or x is equal to a cos omega t is obtained by taking the initial position of the particle to be how much? That is, initial angle of the particle to be how much? When theta naught is equal to, how much should I write? Theta naught or phi naught, whatever it is. I hope you are comfortable with phi. When phi naught is equal to how much?
0 degree.
0 degrees. I hope you are able to understand. But it is not necessary that the particle should always start from x-axis. Or it is not necessary that the particle has to start only from y-axis. We don't. The particle can start somewhere from between also. Okay. Then how you're supposed to deal it. See, this is actually a mathematical concept. We call it as rotation of axis. Okay. Concentrate, guys. Concentrate. There is any doubt, get it clarified. I take this. Suppose the particle, instead of starting from x-axis, what if it had started from this point? If I call this point as P, and let's say it has made the same rotation P dash, then it will be something like this, no? Where I'm calling this angle also to be theta. But here, the important point to be noted is, here it is phi naught. Are you able to visualize the difference between both the diagrams? In the case of first diagram, OP was coinciding with x-axis. In the case of second diagram, OP is not coinciding with x-axis. Rather, it is somewhere in between x and the y-axis. Means it is not making phi naught, which is equal to 0. So phi naught is a non-zero value. In this kind of a scenario, how are you going to write the displacement equation? Okay, that is a very, very simple thing. Y is equal to a sine of, you're not going to disturb anything of this omega t. The only additional factor is you will add a phi naught to it. Guys, am I clear?
Yes, sir.
Okay. Or if I write it in terms of x, how am I going to write? A cos of omega t plus phi naught. Only important point to be kept in your mind is, if you take anti-clockwise to be positive, clockwise should be negative. That's it.
So
Okay.
could you show the second diagram?
Sure. Okay. There is any doubt, get it clarified.
Thanks, sir.
Okay. So if you have a clarity about this, we can actually solve a problem. See, for example, let's take example 14.4. Figure 14.11 depicts two circular motions. The radius of the circle, the period of revolution, the initial position, and the sense of revolution are indicated on the figures. Okay. Obtain the simple harmonic motions of the x projection of the radius vector of the rotating particle P in each case. So they are expecting you to write the expression for the particle's rotation along x direction. Okay. Let me copy this. Clipping it, copy. Okay. Now tell me, what are we supposed to do? So I'll call this as first. This is first, this is second. Let us concentrate on each thing individually. Okay. So here they have told at t is equal to 0, the particle, the point P is not starting from the x-axis. It is somewhere between x and y. So what is the initial angle made by it? I want the initial angle in terms of radian, not in terms of degrees. So how much is the initial angle made by the first particle? Are you guys there?
Yes, sir.
So what is the angle? They have given it, no?
5/4.
It is pi by 4. Very good. So phi naught is equal to pi by 4. Let's collect all the data. Radius is equal to amplitude. right? Time period is how much? That also they're given. Sorry.
4 seconds,
Time
sir.
period. It is
It's
4
given 4
seconds.
seconds, sir.
It is 4 seconds. And the particle is revolving in anti-clockwise direction. Let's say its angular velocity is omega. Okay. Now they are expecting us to write the expression for x direction. So x is equal to a x direction means cos of how much? Omega into
T.
small t plus
Phi naught, sir.
phi naught. Now substitute everything. A cos of, since omega is not given whereas time period is given, can I write it as 2 pi by capital T into t plus phi naught is pi by 4? So A cos of 2 pi by 4 into t plus pi by 4. You guys tell me. So it will be A cos of pi t by 2 plus pi by 4. Hope you understood.
Sir, can you explain the third step? How 2 pi by 4 t came, sir?
2 pi by 4 t. 4 t didn't come. 2 pi by capital T. In the place of capital T, I substituted 4.
Okay, sir.
I hope it makes sense. So let's check with the book answer. 1 minute. Unfortunately, it's cancelled. Things are not clear here. If you have textbook, you can refer it. Okay. Case 2. Try this, no? So radius is how much?
B, sir.
That's right. Capital T is how much?
30, sir.
30 seconds. The particle is revolving in clockwise direction, unlike the previous one. So tell me. And phi naught is how much?
It's 0, sir.
Why is it 0?
Yes,
Phi
it's
naught is the
from clockwise.
phi naught is the angle measured with respect to x-axis.
90, sir.
It is 90 pi by 2. Okay. So x will be equal to how much? A omega into cos of omega t. Same logic plus phi naught. 1 minute. What did they do? Plus phi naught. Tell me. So x will be equal to A is how much here? In this case, it is B. Oh, sorry. No omega, no. I wrote the expression for velocity. Sorry. So it is A cos omega t plus phi naught. In the place of A, I'm writing it as B because the amplitude is B. Cos of. In the place of omega, it will be 2 pi by 30 into t. The only difference that is going to appear here is with respect to phi naught. So what is the difference? In the previous case, the particle was revolving in anti-clockwise. So phi naught was positive. In this case, it is revolving in the negative direction. So what will be the value of phi naught?
Minus pi by 2, sir.
That's it. Minus pi by 2. So it will be B cos of pi by 15 times t minus pi by 2. Are you guys able to understand? Simple,
Yes,
right?
sir.
So this is how you write the expression for displacement of the particle.